Hi guys, Miss McQuaid here. And I'm going to talk right now about concentration. So, we've been talking about solutions, and we know that all solutions have two parts. The solute is the smaller of the two parts, and the solvent is the larger of the two parts. So, concentration is a ratio of the amount of solute that you have, the amount of salt or gas that is dissolved, to the total amount that you have. So kind of like how percent composition by mass is part over whole, concentration will also be part over whole, but that part will be the solute. Now, there are two ways to measure this, but we're going to write this down that it is the ratio of So we say the ratio of solute to solution. Now the way in which we measure the solute can be in grams, it can be in moles, it can be in different amounts. But when we think about the solids, like I'm going to use today sodium chloride. Here's my bottle. Sodium chloride, and knowing the mass of sodium and the mass of chlorine, I can figure out that there are 58.44 grams per mole of sodium for sodium chloride. So each mole weighs 58.44 grams. So what I'm going to do is show you how to make one kind of solution today, called a molar solution. So, when we have molarity, we're going to measure this in So, one way that we're going to talk about today to measure concentration is called molarity. Now, as you probably imagined, molarity uses moles to talk about the amount of solute. So, what I've done is I've massed out 1 mole of sodium chloride here. Now, remember that sodium chloride has 58.44 grams in 1 mole. So, I needed to measure out 58.44 grams for NaCl. Na has a mass of 22.99 and Cl has a mass of 35.45. So when you add them together to find the formula mass, that's 58.44 grams. So I've measured out 58.44 grams here, and I'm going to go ahead and add that amount of solute into my beaker. All right, so if you notice, there are graduations on my beaker here. And I'm going to go ahead and mark the 1 liter mark. So, on my big beaker here, I marked my 1 liter. So if I wanted to make a solution that had a molarity equal to 1. I would add 1 mole of salt and 1 liter of solution. Notice I'm not adding 1 liter of water. I'm not adding 1 liter of solvent. Stir with a pipette. All right, so now that this is completely dissolved, notice there's no more solid at the bottom of the beaker, and I have exactly 1 mole per 1 liter. All right, so now that we've talked about that this is a 1 molar solution, I wanted you to be aware that if I had used a different salt, say I had used sodium carbonate instead, right, which we used in the lab, sodium carbonate, instead of using 58 grams, here I would have to have put 105.99 grams into my solution to make a solution that is the same concentration. All right, so now what about dilutions? What about if I wanted to dilute this solution? What if I wanted to have fewer particles in this solution? So, if I took this solution and I poured it into another beaker, and on this beaker, notice it goes up to 600, so I'm just going to go ahead and mark my 500 milliliter mark for you guys so you can see it better, right there. All right, so let me just scroll down. There we go. So there's my mark right there. Now, actually, I'm going to go to this screen. So here are my 2 beakers. This beaker here has a 1 molar solution of NaCl. So I'm going to go ahead and represent my particles of Na and my particle of Cl. Let's go ahead and make my Na blue, and let's make Cl green. Oops, green. All right, so those are my Na and my Cl molecule ions within my solution. So let's say that I have, oopsie, there we go. Let's say 2, 3, 4, 1, 2, 3, 4. Let's make 6 of these. All right, so let's say this is my original beaker, and I have, let's just say 6 representative particles, but we know that when they dissolve, these particles are going to dissociate. So they're going to spread out evenly throughout the beaker. All right, so I'm spreading these out, dissociating the particles. Move this guy over here, move that guy over there. Ungroup, dissolve, right? So when I'm ungrouping these particles, that's the dissolving happening. Dissolve. All right, so now imagine there's also water in this beaker that I'm not representing the particles of. So this is also filled up with water all the way up to the top. Now, if I was to pour half of this solution into my other beaker, so now I have, there's the mark, 500 milliliters of a 1 molar solution in this beaker, and I have 500 milliliters of a 1 molar solution in this beaker. So just because I split the solution into 2 beakers doesn't mean I change the concentration, and the ratio is the same. So if I was to move 1, 2, 3, and 1, 2, 3, right? That's representing my pouring the solution into the other solution. The concentration of these 2 solutions are the same. Now, the water level in this higher beaker is now half as high, and I'm also going to show that I have the same amount of water in my other beaker, right? So the idea here is that these are both 500 milliliters of a 1 molar solution. So let's figure out how many moles there are in each beaker. Notice that I'm showing that the half of a mole of NaCl is in each beaker. Started out with 1 mole, now I'm going to say that half are in each beaker. Notice that I'm saying that there's half a mole and half a liter. The solutions are still 1 molar because the concentration is that ratio. So half as much solute and half as much solution is the same concentration as before. But what would happen in this beaker, the larger beaker, if I added water without adding any more salt? What would happen if I just added more liquid water all the way up to 1 liter. What would happen to the concentration in this beaker? Would it be more or less than it was before? How much more or how much less than it was before? So I'm going to represent that I added more water. And in this beaker, now I'm going to cross this out because I've changed my solution. So now you can see that as I dilute my solution and my particles of salt are going to spread out evenly throughout the solution. All right. I'm now going to have a solution that is half as concentrated as it was before. So here I have twice as much water and the same amount of solute, so therefore my solution was diluted from 1 molar to 0.5 molar. But what if I had a different amount of solution? What if I had used a smaller amount? Any amount I use, I can always figure out how many moles I have if I know the original concentration. So here's my smaller beaker of my 1 molar solution. Here, the smaller beaker of my 1 molar solution. What if I took 50 milliliters of my 1 molar solution? And I added, up here is the 200 milliliter mark. So I started with 50 of 1 molar, and I'm going to dilute it up to 200 milliliters. So I could figure out, ooh, I overshot it a little bit. That's good. So I can figure out how many moles of solute I poured into this beaker. That number of moles didn't change when I added the water. So let's figure that out. If I had 50 milliliters of a 1 molar NaCl solution, how many moles of that solution would I have? Let's do the calculation. So notice the first thing I did was convert 50 milliliters into liters. And then once I knew the volume and I knew the concentration of that small amount that I placed, the concentrated amount that I placed in the bottom of the beaker, and then I brought it up to volume. So the number of moles of salt that were contained in that smaller amount that are currently contained in this beaker so 1 molar. So now I know that I poured 0.50 moles of NaCl into that beaker. I then added water up to 200 milliliters. So the question is, what's the concentration now? So I know that I have 0.050 moles. And I know that it's taking up 200 milliliters. So I can find my new concentration using those values. Notice I needed to convert my milliliters again. So 0.05 divided by 0.2 tells me I have a 0.25 molar solution. Think about it another way. There's 200 milliliters in this solution. I added 50 milliliters, which is 1/4 of the total volume. So my concentration is 1/4 of the initial concentration. We have a nifty little equation for this, where we say that the moles of the initial solution and the number of moles that are transferred are equal to each other. By cross-multiplying this molarity equation for moles, you can say that moles is equal to the molarity times the volume of that solution, which we saw here when we cross-multiplied to find the number of moles. So we can say that So here C stands for concentrated and D stands for dilute, and the molarity of the concentrated sample times the volume will tell you how many moles there are, and the molarity of the dilute times the volume of the dilute will tell you how many moles there are. We could have used this equation to solve for the molarity of the dilute by just plugging right in, but I wanted to show you where it came from. All right, that's all on molarity. Thanks, guys.